The Lightweight Structures Laboratory, LSL Research Group, designed the kit of nuts and bars to construct translation grid shells manufactured with different sustainable and recyclable materials, and with the following characteristics. Just one universal nut and bars with constant length are necessary to build grid shells with variable curvature and size. 2. Structural elements can be stowed in small packages to use the minimum space. 3. Effortlessly manage and transport. 4. Rapidly and easily erection. 5. Use of sustainable and recyclable materials. 6. After dismantling and using the same nuts and bars kit, building new grid shells with different sizes and curvature is possible, a process that can be repeated as many times as desired. The kit's manufacturing materials are Salinas free anneal for the nuts and different sustainable or recyclable materials such as bamboos, plastics, or paper boards for the bars. Translation grid shells have geometric properties that trigger their effortless ensemble and construction. The first author of this article published in 1982 these geometric properties in his doctoral dissertation. The coplanarity of 4 nodes on the grid surface stands out, making it possible to cover the structure with flat plates made of different materials such as jute, structural membranes, glass, plastics, timber, or concrete.
In the bars and nodes construction kit, we consider the use of plastic materials that met the structural requirements under a load of 2,100 newtons at each node. Also, we implemented a methodological follow-up from the conceptual design to the finished product. A feasibility study was realized to create the parts that make up the nodes. Simultaneously, each element's structural analysis was carried out, as we can see in the slide. It was necessary ribs to each part and to make the parts thinner. Both the nodes and the butt joints geometric configuration were established under the design rules from plastic part and its assembly. About the manufacture, we use polyamide 6Cs with 30% of glass fiber from Salinas free anneal to manufacture all of the components. And we found in the literature that when the piece's life cycle ends with this material, it is possible to recycle them if specialized additives such as blue bottling are added. Present in the slide, each part was produced separately in a mold of 2 cavities. Once as both configurations were designed, the quality was verified through a cavity filling analysis with the software mold flow part advices. The position of both pieces was determined based on the cavity's filling balance during the injection molding. In the next images show firstly the mold designed and after the physical mold attached to the DEMAC injection machine with a capacity of 200 tons of clamping force. Both pieces were obtained by injection molding in the plastic process laboratory of the engineering faculty of UNAM. Once the pieces were obtained, the corresponding assembly was carried out. Figure A shows the nodes, which are compounds of 2 interlaced circles with structural reliefs. This configuration continues to preserve the general geometry established in the conceptual design. As for figure B, it is shown the butt joint composed of 2 parts facing each other. The node is connected to the butt joint by metal bolts. Those elements were designed to ease the manufacture of the injection mold. We can also see the final configuration of the nodes. attached to various bamboo bars that are part of the kit to construct translation grid shells. To resume, we can successfully obtain a node for the translation grid shells by using the methodology presented in this work.
The LSL Research Group designed the MODUNAM III pavilion, constructed with the knots and bars kit. This pavilion demonstrates the kit's performance at the exhibition of innovative lightweight structures organized by the IASS Working Group 21. The pavilion has knots made of triangle and bars made of PVC. The research group has developed projects with bars made of different sustainable materials, such as bamboo or paperboard, but they choose PVC to facilitate its assembly on site and comply with the exhibition rules. In the first stage, the pavilion demonstrates the construction of a translation grid shell with positive Gaussian curvature. The second stage of the pavilion demonstrates the construction of a translation grid shell with a combination of positive and negative Gaussian curvature. The pavilion structure came out by modifying the pavilion form in the first stage and using the same knots and bars previously used in the first stage. Emergency structures are today of utmost importance. Architects, engineers, and structural designers face today's challenge to conceive, design, and construct sustainable emergency structures. The LSL Research Group presents a prototype for an emergency hospital intended with the knots and bars kit. Thank you.